Hello, this is Mr. Block, and today we'll be taking a closer look at the 2002 FRQ, question number 4. Before we begin, let's go over a few key points that must be understood before completing this problem. First, we need to be familiar with the relationships between antiderivatives and derivatives. So, for example, a of x is equal to the antiderivative of 0 to x bt dt. So if that's true, then a prime of x is equal to b of x, while a double prime of x is equal to b prime of x. Second, we need to understand how derivative looks when graphed. This means understanding when the derivative is increasing or decreasing by looking at an antiderivative. So, f of x decreases when f prime of x is less than 0. F of x increases when f prime of x is greater than 0. So the same is for concavity. So we have to understand the concavity of an antiderivative by looking at the graph. So it's concave up, graph's concave up when f double prime of x is greater than 0, and concave down when f double prime of x is less than 0. Okay, so knowing these two key points will help us when we're looking at this problem. So, the problem gives us the information that g of x is equal to the antiderivative of 0 to x f of t dt. They also give us the graph of f. Alright, so I think now we're ready to go into the problems. So, A is asking us to find g of negative 1, g prime of negative 1, and g double prime of negative 1. So g of negative 1 is equal to negative 1, 0, f of t dt. Okay, so this is where a lot of people will start to make a mistake. As you can see, the smaller number is on top and the bigger number is on bottom. But we need to reverse those and make the antiderivative negative. And if you don't, you'll get the wrong answer. So, if you're moving from right to left, it's going to be negative. So, let's take a look. So, you do the height times the base divided by 2 because it's a triangle, and you'll get 3 halves. But since there's a negative right there, it would be negative 3 halves. There you go. Alright, so now we're trying to find g prime of negative 1. G prime of negative 1, which is equal to f of negative 1, as we can see over there, is that point. So that point is 0. G double prime of negative 1 is equal to f prime of negative 1. And this is simply just asking for the slope at negative 1, and that is 3. So you can go 3 up and 1 over, and that slope is 3, 3 down, and 1 over, and that slope is 3. So that means this line is constant with a slope of 3. Okay, so I'm going to erase to make a little bit more space, but we're going to be moving on to B. Alright. So B is asking us, for what values of x in the open interval negative 2 to 2 is g increasing? Explain your reasoning. So, from negative 2 to 2, g is increasing when when f of x is greater than 0. So this is the antiderivative of f of x. So then we have to find g prime of x, which is equal to f of x is greater than 0 between negative 1 and 1. So the answer is negative 1 to 1. And then the reasoning behind that is that g prime of x, which is equal to f of x, is greater than 0 on this interval. Alright, so that was B. Let's move on to C. So C is asking us, for what values of x in the open interval negative 2 to 2 is the graph of g concave down? Explain your reasoning. So as we figured out before, concave down is when g double prime of x is less than 0. So what is g double prime of x equal to? G double prime of x is equal to f prime of x in this graph. So where is f prime of x less than 0? Where is the slope next than 0? It's always positive here and then always negative here. So then the answer would be 0 to 2. All right. So I'm going to erase this to make more space, and we're going to move on to D. D is a little bit trickier because it's more conceptual. All right, so D. D is asking us, on the axis provided, sketch the graph of G on the closed interval -2 to 2. So this is the graph of F. So now we need to find the graph of G. So you have to derive the derivative of this graph. So D. Okay, so on the graph of F, this whole thing is sloped up, while this whole thing is sloped down. So from here to here, if it's sloped up, that means that it is going to be concave up from -2 to 0, and concave down from 0 to 2. So now we just need to find where we have zeros. So there's going to be a 0 at -1 and a 0 at 1. Now we just need to find where those are going to be. So if it's concave down from here to here, we can imagine that's going to look like that, and it's going to be 0 there, slope of 0 there, going up. And then if this is going to be concave down, we can imagine that's going to look like this, with 0, slope of 0 there and there. All right, so we just went through A, B, C, and D, and we used these key points to figure them out. So I hope this is useful, and good luck. Thanks. Bye.